Tower, out of some wood and a big old, and yeah.
When I retire, I want a bell tower. He uses the heck out of that thing. I want it to ring on the hour. My wife's like, not happening. I'm like, hey, when I retire, I'll build it.
Because he
And I'll
saw
put it on.
Hunchback of Notre Dame, and
Yep.
since he saw that, oh man.
So there was a Trivial Pursuit question. What was the Hunchback's name?
Quasimodo.
Quasimodo.
I would think a hunchback for $100.
Be that way. All right. Questions on combustion. Combustion emissions. Okay, good. Good. So we're going to do a quick overview of the ignition system on this. And by today's standards, this is kind of a barbaric system. By today's standards. Okay. But again, we're not building a performance engine per se. We're attempting to build an engine for longevity. If you want a performance engine, you shouldn't be looking at Cummins. Now, there's Cummins guys that would argue that point with me, and I'd have to say, if you're talking to me about a 15-liter dual overhead cam diesel, that's a different story. But we're talking about a pushrod 8.9, different story. Okay. So our ignition system consists of 6 plugs, 6 coils, an ignition control module, an ECM, engine control module, engine position sensors, manifold pressure sensors, 12-volt switches. So I need, now for those of you that remember Phil's course, Phil said that for a circuit to be complete, there must be a complete path back to ground, correct? Okay. The one exception to that is the spark plug. Okay, it's a complete path. Or actually, let me back that up. There's a path back to ground, but it's not a complete path. I have to force electrons to do something they normally wouldn't do. I have to force my electrons to jump an air gap back to a conductor to find their path back to ground. That's not something they normally like to do. Okay? And it's that path, that traveling across the air gap, that generates the heat necessary to light off to start my combustion process. Okay. Now, what we have is a capacitive discharge with the capacity for multiple sparking or multiple discharges per combustion cycle. So what I'm saying is this. Because the fuel we're using is so crappy, it has a very low heat value. It's a dry gas, so it is hard to ignite. So I have to possibly fire the spark plug multiple times per combustion event to start the combustion event. If I fired it just once, bzz, it may or may not combust. Okay, or it might start the flame front and then extinguish itself. But if I fire the spark plug multiple times, that ups the possibility of a complete combustion process. Doesn't guarantee it.
Is that just for the LNG and CNG?
No.
Or for all?
Not necessarily all, but Chevrolet started this for their high-performance cars back in the 70s, MSD. Was it the 70s, Mike? You're the hot rod guy.
I don't know when, but I'm familiar with MSD.
Multiple spark discharge. They did it on the high-end cars because the amount we squeezed the air, the compression ratio, was higher and harder to light the fuel, so they had to figure out a way to maintain the spark plug firing to light off the fuel on these high-performance cars. So Chevrolet came up with, well, let's just discharge the spark plug multiple times. And that's what they did. Okay? So a lot of cars are still running that. We're doing it not for performance because the fuel is crappy. Now, the way we can do that is we have a capacitor in the coil. Or in the ignition driver, in the ignition control module. This capacitor, the difference between a capacitor and a battery is a capacitor, number one, does not make electricity. A battery does, through chemical reaction. The advantage of the capacitor is I can charge it quickly and I can discharge it quickly. Multiple times. I can discharge a battery quickly once. Let me borrow that wrench of yours. Jeff, and I'll show you.
Better put a face shield on.
Yeah. Don't give me that Cal Proto crap. I want a good one, man. Right? Give me that high-end, long-handled Snap-on, and I'll just drop it across the 2 terminals of battery. Actually, the nickname for that is welding.
Yeah.
Okay? So, with the capacitor in there, I can charge it and discharge it multiple times. Now, my dad worked at the phone company. So one day he comes home with a 10-watt capacitor. He used to throw them at his kids when he'd come home. Hey guys, nice to see you. Ooh, that was funny, right? So he throws it at me, and my brother makes the interception, catches it, and gets lit the hell up. Ah, he's on the ground. My mom comes out. Max, are you trying to kill the kids? My dad's like, don't make kids like they used to. So after that, he limited him to about.
That's good parenting.
Well, today they call it child abuse. But now then he limited it to about 2.5 watts, so just, threw it at the dog. The dog was smart, he backed up. I sold it to him.
Give a kid a good zap, he doesn't touch the outlets anymore though.
No, yeah, we let my dog do that. We let him chew through the TV cord, never chewed another cord again.
Yeah.
In education, folks, they call that negative reinforcement.
Yeah.
Where'd you bury the dog?
Let 'em
Huh?
chew it.
Where'd you bury the dog?
No, we were worried about digging a big enough hole for my brother. Man, oh Chris, you should. He got lit up in midair. He just did the freaking.
They sometimes just-
Great. But the point I'm making with this is, other than how to kill your brother, with the capacitor, that gives me the capability of discharging the spark plug multiple times in one compression stroke. Okay.
Should hit him with a throwback question.
All right, let me have it.
What's the measurement of capacitance?
Farads.
Not for you, for them.
Oh. Alex, I'll have capacity. Well, I missed the Quasimodo one, so I had to make up for it, right? By Michael Faraday, I believe he's a Frenchman. I don't know.
Yeah.
Nonetheless.
There,
no.
yeah. That's it.
Yeah, see, not just another pretty face. I got some knowledge up here. Quiet, Chris. Now, primary inputs in the engine control module for spark timing are engine position sensor. I need to know where my pistons are at, right? Manifold pressure. Why do I need to know manifold pressure? What the hell does that tell me? How much load the engine's under. The heavier the load, the easier it is to light off the plug. The lighter the load, when the engine's running inefficiently, we got to work harder to start the combustion process. So knowing how much pressure is in the manifold tells the ECM, well, what's the engine doing? Okay? So the intake manifold pressure, it's a transducer that generates a signal to the ECM proportional to the air-fuel mixture pressure in the intake manifold. A lot of words just telling you how much pressure is in there. Okay? Uses that signal to adjust the engine's timing. When do I light the spark plug off? Okay, if it's a heavier load, it'll run it a little more advanced. Okay. Input for mass air calculations. So the engine crankshaft measures the position of the engine the engine camshaft speed position sensor measures the position of the engine camshaft by a variable reluctance sensor. Okay, so I have 7 protrusions. Hang on, let me get my camshaft. Make this a little easier.
You found it.
What it looked like inside there.
I'm still listening.
Hey, man, camshaft.
Oh, you thought he was gonna surprise you?
So the camshaft sensor has 7 little notches on the back of the cam gear. Here, catch.
Let's see it curl that.
Yeah.
One hand.
Not happening.
I'm gonna be sore.
Very funny, Frank. You're gonna have to finish class.
We're all witnesses. OJI.
So, on the form that says, were there any witnesses, I say, I need another page. You want pictures too? Because I got those. Well, why do they look so shocked? Because they can't believe I was stupid enough to try that.
If Lorena was here,
Oh.
we'd have it on video.
No, you'd believe it, yeah.
Yeah, just to be clear.
Just to be clear, he's
City's
double
got
up.
it on video too.
Probably on Facebook too, right?
No.
All right.
His funniest home videos.
No, OCTA is funny, it's just the classroom videos. But like, I can't believe that guy's not in prison. All right.
Yeah.
What are you talking about him for? I'm not.
Medically retired.
All right. So I have these protrusions on the back of my cam gear. Okay, and these are picked up by a sensor. Now, each one of there's 6 protrusions that are relatively evenly spaced around the circumference of the cam gear. But yet there's a 7th one that's relatively close to one of them. This,
Reset.
what's that?
Just to reset.
That's the reset button, exactly right. So, this tells the computer the firing order, the 6 of them. The 7th notch tells it to start over. If I just had 6 there, it'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and keep going. But I've got, 1, 5, 3, 6, 2, 4, repeat.
In between the 2 notches, that's TDC then, right?
No,
No?
it's about 40 degrees before top dead center. Okay? So whenever the cam gear protrusion passes the camshaft speed sensor, the ISLG engine utilizes 2 Hall effect sensors, one located on the camshaft and one located on the crankshaft. So I use 2 sensors to tell me where my piston is at precisely in the bore. The camshaft gives me the neighborhood, 40 degrees before top dead center. The crankshaft tells me exactly where that piston is in relationship to the 720 degrees it takes to fire that bad bear off. Everybody following me on that? Okay. I use that information based on the pressure in the manifold to adjust when do I fire the spark plug. Do I fire it early, advance the timing, or do I fire it late, retard the timing? Early, advance, the piston is further down in the bore. If I delay or retard lighting off the spark plug, the piston is further up in the bore. Okay? Six of the 7 protrusions on the cam gear are located, 47 degrees. I'm sorry, I said 48. Angles before top dead center. So whenever one of these passes the sensor, it tells the computer that that particular numbered cylinder or piston is 47 degrees before top dead center. Okay? The cam sensor sends a signal to the ECM based on these protrusions passing the end of the sensor. It tells the ECM the firing order. Okay. The 7th sensor simply tells the computer to repeat the firing order. 90 degrees before cylinder number 1. So this passes, it says, oh, cylinder number 1 is 90 degrees out, right? 90 degrees before top dead center. Then the second one passes, it says cylinder number 1 is now 47 degrees before top dead center. Cylinder number 5, cylinder number 3, cylinder number 6, cylinder number 2, cylinder number 4, cylinder 190, cylinder number 147, so on and so forth. See what I'm saying? I'm going to lay that down. That's not relatively safe to do that. That's right, Sporto.
That was a great show.
I fixed a broke down Army bus from the National Guard that blew the parking brake line off the parking brake chamber. We're out in the middle of BFE, coming from Fort Irwin, out of Barstow, or not Barstow, but up in, yeah, Barstow. So there we were dead in the water, with a brake line blowed off. I crawled in there and said I need a 9-volt battery, a hose clamp, a tie wrap, and a screwdriver. The guy looked at me like, what are you smoking? So I took the battery, stuffed it in the line, I used the hose clamp to tighten the battery in the line, and I tied it up with the zip tie, and we were able to get the brakes off and drive it back to the base. The guy goes, oh, you're a freaking MacGyver, aren't you? I said, well, it's either that or sit in the desert and beat buzzard bait. You choose. I said, oh, by the way, while I was under there, I found about 8 violations that CHP might be interested in. You know, like the exhaust leak below the hole in the floor. Yeah, that's always a, that's always a plus. So the crankshaft position sensor picks up its signal from the crankshaft gear. That's that big sprocket we saw in the back of the crankshaft when we put the crankshaft in the engine. Okay, it uses that to relay information about piston position to the ECM. Okay. If this signal were to become interrupted, it might cause intermittent misfires or a no start. So if I got my crankshaft sending piston information to my ECM, and all of a sudden that signal starts to become intermittent or, for lack of better terms, blurry or fuzzy due to sensor failure, or maybe the sensor's just loose in the bracket and starting to back out, the ECM is going to start wondering, well, what the heck's going on? And it may not fire a cylinder. It may not fire a spark plug based on this erratic data. Okay? If that sensor fails altogether, it being the ECM, can look at piston position solely based off the camshaft. Now, it's not going to be precise, but it doesn't, at least it leaves the engine running with the ability to keep moving the vehicle. It's not going to run well at all. Okay. So if the engine crankshaft sensor fails, the engine can run off the cam position sensor. However, random intermittent misfires can occur as the ECM looks back and forth between the sensors to look for the most valid data. So I've got a failing crankshaft position sensor, and I've got the ECM going, okay, we'll look at the camshaft. Oh, let's go back and look at the crankshaft. Oh, that's still bad. Let's look at the camshaft. And so in this hunt for a good signal, or an accurate signal, you're going to have some misfires. Follow? Okay.
Misfire detection, always fun.
Oh, the way Cummins does it is beyond belief. It's not like most cars where if the cylinder doesn't fire, you don't pick up the momentary acceleration of the crankshaft. Oh no. They look for residual spark and all this other crap. It's just beyond belief the way they look for misfires.
Oh,
It
wow.
makes no sense.
So simple to just look at your crankshaft tone wheel and
You would think,
late, okay, misfire code.
or it just looks for to speed up when the piston fires.
Yeah. Detroit does it like that too.
Yeah. So the ECM looks for proper ignition timing based on these two sensors, where the camshaft is, where the piston's at. The 7th protrusion on the cam gear is located 30 degrees after cylinder 4. So after cylinder 4 fires, 30 degrees later, it's going to see that 7th protrusion. And that 7th protrusion tells the ECM that cylinder number 1 is the next cylinder to fire, and then to repeat the firing order. Because the firing order is stored in the ECM. It knows that it's 1, 5, 3, 6, 2, 4. It just needs to know when to fire each one and when to start over. And the 7th protrusion tells it to start over. Or like Virus said, reset. That's a good word, I like that, reset. Repeat, reset, start over. Okay? So because of the location on the cam gear, the signal from the 7th protrusion breaks the constant timing of the other 6. So if you were to look at it on an oscilloscope, so you'd have that little hiccup right there. That breaks the constant tone of the other 6. So 1, 5, 3, 6, 2, 4, repeat, 1, 5, 3. So that 7th protrusion indicates it's time to, the next cylinder to fire is number 1. I watched the guy in Long Beach, I thought it was kind of messed up. He ground off that 7th signal and let the guy put in the engine. I thought he was joking around, and then they had the nose start. And everybody's like, what the hell?
Ran the firing order once.
He's getting all these codes. And then I looked at the camshaft, and it had a peculiar casting, not a problem, but a defect. I was like, that jerk off put that thing in the motor. Or he let the guy put it in the motor. Because that's not something you would check on assembly, just cam gear. I was like, oh, that's messed up. That guy about a month's suspension. He earned that one. Okay. So what's that? No, the guy was a dirtbag. He was about a 5th-degree dirtbag. So the ECM uses the frequency of these signals resulting from the 6 evenly paced protrusions passing the engine cam sensor to calculate engine speed and with the manifold pressure adjust the ignition timing. Okay, pretty neat. Recognizes the 7th signal from the 1 unevenly spaced protrusion as the indicator to start the cycle over. Okay. Now, the ECM does all the thinking. It's the brains of the outfit. It does all the timing calculations, all the fueling calculations. And then it simply sends a signal to the ignition control module, fire. That's all it does. Now, the ICM defines the ignition timing for each cylinder. The timing signal is defined by the intake manifold sensor and the camshaft sensors. The ECM uses these signals to adjust everything. Okay? Sends a spark timing signal to the ignition control module, and the ignition control module uses that to fire the appropriate coil. Okay? So the ICM houses the coil drivers and the capacitors to fire the coils. It gets its trigger from the ECM. After the ECM calculates when it should fire the cylinder based on manifold pressure, piston position, it simply sends a trigger to the ICM. So the ECM receives all the inputs: camshaft, crankshaft, pressure, and sends that spark timing signal to the ICM. Then the ICM sends ignition signals out to achieve the correct firing order, 153624. So after the ECM sends a spark reference signal, that's what Cummins calls it, to the ICM fires the plug. Then the next plug in the correct firing order each time it receives a spark timing signal from the ECM. So the ICM knows the firing order. The ECM knows where the pistons are at. So the ECM calculates the ignition timing for each cylinder. And when the ECM calculates the timing, it sends a trigger or a spark reference signal to the ICM. It says fire, 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 fire. And the ICM goes 153624, 153624, 153624, based on when the ECM tells it to fire. Okay? So after firing all 6 plugs, the ECM sends another spark reference signal to start over. 153624 reset, 153624 reset. And that's what the ICM does.
Sounds like a boring job.
Yeah. Now, the ignition control module contains a DC to DC converter. Means it's a step-up transformer. Okay. DC to DC converter and a separate coil driver for each of the spark plugs. Okay, so I have a DC to DC converter that steps the 12 volts that's fed into the ICM, and it steps it up to 300 volts. Yep, I got lit up by one in class. Wasn't paying attention. Out in my own little world.
Can we see that?
Yeah, no. And it was with, you remember, did you ever meet Cal Macy? Oh, that guy was a genius. He started the alt fuel program
Goes
based.
on the coil pack there?
Yep, right here. I inadvertently was checking voltage and I touched one of the leads. And it got lit up. 300 volts. Numbed the arm. Oh, that hurt. Now this voltage, this 300 volts primary voltage, charges my capacitors. Each coil, this voltage charges the capacitor in each of the coil drivers. So each coil has a capacitor. Now what a capacitor does is it simply stores voltage. It does not make it, it stores it. Okay? And it can charge quickly, and the capacitor can discharge quickly repetitively. Over and over and over again. This is the advantage over a battery. We could not have an MSD ignition system, a multiple spark discharge ignition system, using straight 12 volt battery voltage like the cars of the early years. Because the battery couldn't charge the coil fast enough to discharge it fast enough. It wouldn't work. Okay. So the spark timing signal received from the ECM causes the ICM to close a trigger. Now for a coil to work, I've got two windings in a coil. Okay. One winding is charged, and then it's fed voltage, and then the voltage is turned off rapidly. Charge, discharge. And this rapid turning on and off of the primary voltage winding in the coil will induce a secondary voltage in the secondary windings. This is where we get that 50K, 50,000 volts necessary to jump the plug. Right? Now back in the day, they used to have a mechanical switch. We called them breaker points. That would literally open and close, open and close, open and close to induce the secondary voltage. And for the automobile of the era, it was fine. Now they went to what they call transistorized ignitions. Transistor is just another name for an electronic high-speed switch that can open and close at much higher rates of speed than the old mechanical points. Problem with the points is it was positive voltage, so they would arc. So you'd have to file them and reset the gap over time. Okay, with this, huh?
Then you had dwell time too, because you could just set.
That's the build time and all that. Yeah, angle and dwell.
And
Well, dwell would be your gap.
yeah, well, how much time is charging the coil?
Which would be how long it's.
Like 35 degrees.
Mm-hmm.
Yeah, how long it's older. Yeah.
The coil. So.
I still got an old tack dwell meter in my garage. I found it the other day. That's just funny.
I needed one.
Did you?
I don't have one. I have a timing light,
Yeah.
but I don't have a draw meter.
Yeah. I don't know what I did with it. It's probably somewhere in a box.
I changed it out. I put a transistor
Yeah.
ignition in it.
Now, piston reaches the correct position in the compression stroke. The ICM closes this switch, this electronic switch, based on the trigger or spark reference signal sent from the ECM. So the ECM sends the signal to the ICM. The ICM closes the trigger, okay, to the ignition coil. The current flow in the primary windings induces a voltage in the secondary windings, and this high voltage is delivered to the plug. So the reference signal to the ICM causes the ignition control module to simply close a switch, which then allows the 300 volts to the coil to induce a voltage in the secondary windings in the coil to give me enough voltage, pressure, to jump the gap. And this voltage comes from the capacitor. We okay, Vanessa?
So that's the switch down there?
The switch is right in here.
Okay.
Okay? This is the capacitor. This is the schematic symbol for capacitor. Closes the switch, discharges the capacitor, which fires my plug. So the voltage continues to build until it is great enough to cause the current to jump the air gap. Again, this is that one exception to what Phil was telling you. You must have a complete path to ground. We don't have that on the spark plug. We simply have a gap. that we force the electron to jump because we give it enough pressure. Remember, voltage is pressure. So by giving it 50,000 volts, it has enough pressure to transverse that gap through air, which is an insulator by all other nature. Okay.
And you're compressing that insulator too.
Yep. So the current flow across creates a heat path of about 30,000 degrees Fahrenheit. That's sufficient enough heat to light that fuel charge off. Now, if I just do that once, and I get a brief 30,000 degrees Fahrenheit, and that's it, I may not light that fuel off. It may not be sufficiently long enough to light the entire cylinder above the piston to ignite it. I mean, I want to start a forest fire, but if I can't even light one tree, we're not going to get a good forest fire, are we? Okay. Not that I set forests on fire.
At least you don't do a bad job doing it.
No, no.
Smoking the barrel will be after you.
He's a big guy, too. 8 foot, 900 pounds. Yes.
No, I'm not that big.
I'm not going to touch that because he hasn't filled out my paperwork for my bonus yet, so I got to be nice. Scary part of it is, he says, name something you did good this year. I'm like,
Bonus?
yeah, I know.
You control his bonus? Really?
Kind of. He says, name something you did good this year. I'm like, I got to think about that.
Well, if I decide he's deserving of one, I have to write up a justification. So I
Yeah.
guess I kind of control it in a way.
We don't write anything if you
No, I don't.
Frank, the class is helping his performance. Keep that.
My hand hurts, I can't write.
Especially without a fresh cup of coffee every morning.
When your voice. I'm not feeling well, Frank.
We have way too much fun. That's one of the reasons I like working. When they set the bar low, man, it's not hard to hit. All right, so here's the deal. If I'm trying to set a fire in this combustion chamber, if I'm trying to combust this fuel with not a lot of heat, I may have to generate that 30,000 degree voltage, 30,000 degree Fahrenheit, that heat multiple times in that cylinder to start the fire and keep it going. Right? This is where that multiple spark comes in. Fires it off, keeps the flame front going enough to combust the air-fuel mixture in the cylinder.
It happens so quick it looks like a continuous
It,
one though,
it
right?
does. I had a prop that would actually fire 4 spark plugs. It was based off the Detroit 50. And when it was firing the plugs out, it looked like a purple plasma, or a laser, if you will. I mean, that's how often it fired. And that was not MSD. So yeah, it's so fast. It's firing in milliseconds. Okay? If the plug is cooler than the minimum temperature, it actually starts acting like a heat sink, pulling heat out of the cylinder. Okay? Starts absorbing heat. If the cylinder contains too few air-fuel molecules, when the plug fires, the combustion may not start or may start and die. So if the air-fuel mixture is slightly lean or slightly rich, it may not ignite. So having a multiple sparks in there to keep the heat up, eventually it's thought will light off that mixture. Everybody okay so far? Any questions? Wow. Good. So firing the plug multiple times greatly improves the chances for a successful cylinder fire. And we're doing MSD almost all the time. Almost all the time. With the exception of possibly under full load. Okay? But it's in MSD, especially at idle, especially when it's cold. Okay? When you're motoring, not under heavy load, you're just cruising, right? So on the ISLG, multiple spark discharge runs throughout the entire engine operating range. It was originally thought, and I had to get squared away by the Cummins engineers, that MSD was only working at idle and light loads. So when I was talking with the engineer, he's like, no. For emissions purposes, it's going most of the time. Very few exceptions to that. Now the spark plugs themselves. When we first got these buses back in '06, a spark plug cost $75.
Whoa. That's crazy.
What? All?
$75, and it said Cummins on it.
How many miles you get out of that?
At the time, 8,000
What?
miles.
Jeez.
Ain't toxic?
It's gonna be 100,000 miles.
If you're lucky and nobody touches them,
Yeah, I'm going there, but you bring up a good point. It turns out
touch them with their hands.
that the Cummins, the spark plug with the Cummins name on it was made by Champion. And Champion sold that same exact spark plug for about a third of the price. So we said, well, the hell with you, Cummins, we're gonna run Champions. They're like, you like your warranty? You'll run our plug. So we said, you like federal court? We'll see you there. Because we got lawyers, we got good lawyers. OCTA, we don't get pushed around much. All right? So they came, you know, Cummins is like, oh, we don't want to do this. So they backed down. Now the plugs have come down to, I'm going to say like 17, 18 bucks a plug.
Reasonable. And that
How
was
much is
just
a
running
Champion
the
one?
CGS Plus.
Yes. Yeah. And the plug we're running today is much better than the one they initially were installing.
And then when you change the plug, you gotta change that boot also.
Yep.
Which was an additional.
And that boot gets glued to the plug.
Well,
And and the installation time is just crazy because of getting that damn boot off so you can get your spark plug socket on to pull the plug out.
And sometimes they get stuck on the bottom on the base.
need more work.
Did you end up using a different spark plug socket to install for
Yes.
install only?
Yes, thank you, and I'm going there.
I
These-
had the hardest time getting that through my screw.
Magnetic plug.
What
Clean
tool do
magnetic
you have to take those boots out?
We had a tool, Eddie Macias made it. It was a pipe that he put a chamfer in it, right? It was a tube. And as I ran it down the plug, that chamfer would dig between the plug and the boot and pull the boot off the old plug, and then I can get my spark plug socket on it. So basically what it looked like,
Here, go get one.
it's like a straw. It's made of
I still want to see me get hit.
What do they make it out of?
Internet.
aluminum. But what it is, it just comes down.
Probably immune to it. That wouldn't be the first time.
And as you slide it down the spark plug,
Can you make like one of those for each of us, please?
what? I think the first one he made was out of a small galvanized pipe. And you just ground a slight chamfer in it, and you push it down the plug, and it pulls the rubber boot off the plug because it gets melted on there.
And you're tossing the.
Well, you're tossing the plug, so you're not worried about damaging it.
Yeah, so yeah, it's just a matter of getting
We
it
just
off.
tossed the boot too.
Yeah, well, yeah, the boot goes as well. There's no use keeping the boot. I'll see if I got one. I'll try and dig one up to show you. Is it'll have low jack on it, so if you try and walk out with it. Sheriffs will be over here with their guns and the dog. Now, I would love to see someone get chewed up for trying to steal that. That'd be fun. No, I'm kidding. I think I got a couple of sure. Yeah.
They sell those on Amazon.
Well, there you go.
$30.
$30 bucks.
Well, Snap-on sells it too for 50 or 60.
So you can make one and stamp whatever name you want on
Yeah,
it.
made in USA.
Made in USA. Okay.
Yeah, I wouldn't get the one from China. Just saying.
Yeah. Oh my goodness.
All right. You guys are killing me.
This is a 6-pack or a 12-pack.
What's that?
It's a 6-pack or 12-pack from China.
Bud Light virus. How did they come up with coronavirus?
I think that's the name, it's just the 19th strain of it.
Yeah, but how'd they come up with corona?
With the
It's a
name.
crown, it means crown, corona.
The shape
So-
of it.
So when they look under.
Oh, okay. I was being serious. I didn't know how they
When
came
you
up.
look under a microscope at the actual,
It looks like a crown.
It looks like
Like
a
a
crown.
corona.
Yeah,
Oh,
it's been
okay.
around- it's been
The
around for a
virus
long
looks
time,
like
it's
a
just
crown,
different
yeah.
strain.
Yeah, those Chinese
Yeah.
are drinking
You see it
some
on
Coronas.
Kills Crunch, it's just the family of it.
Yeah.
But that doesn't mean you can have a corona
And
like.
supposedly was for animals
Oh,
only.
I saw this picture on Facebook the other day. It's got this Corona beer sitting in the fridge, and everything else is slid off over to the corner.
That's a good one.
I love that crap. That's just awesome.
Stay away.
Yeah, steroids, that guy's got a disease. All right. So the spark plugs we're running, we do not adjust the gap. Back in the day on your Ford, right, you get the spark plug out, you do the gap gauge out, you set it 35 thousandths, right? You tap it on the blender, ding, ding, ding. Okay, yeah, we're good. You thread it in there.
Yeah.
Okay? Can't do that now. I've been told by Cummins, I don't know if this is true, that was because we have the 4-pronged plug.
3-prong.
It doesn't
Maybe
come.
you guys got three.
It doesn't come set with the gap.
No, the gap comes set and it's
It does-
not adjustable and they don't want you checking it.
Oh, yeah, that's good.
Okay, might be 4 or 3, but it looks, you know, if you look at the center of it.
Almost looks like a split fire.
Something like that. Well, that's basically what it is.
Split fire?
Split fire.
Yeah.
And this gap is not adjustable. So if the gap is messed up, if you're looking at the plug and you're like, oh, that prong is bent.
Get it
Cummins,
out.
yeah, exactly. Cummins tells me those prongs are computer set. They're set on a computer in the factory. They're set with a computer, and it's exactly precise. Don't screw with it.
I
Okay?
wouldn't.
Fine. Tell me not to mess with something? Fine, I won't mess with, well, that's not necessarily always true. Okay. So if it looks bad, you reject the plug, you go get another one. The other
You're
thing,
looking, just where it comes out at the bottom, you're looking for the gap if it burns too much, if
Yeah.
there's space there.
so the other thing is, and Chris mentioned it earlier, is they don't want you handling the plug.
What?
They don't want you to handle the spark plug. They don't want you to put your hand all over the insulator.
Oils.
The oils on your hand could develop a tracking, and you have carbon tracking outside the plug. Again,
It doesn't burn it off.
yeah, again, they say wipe the plug down with isopropyl alcohol. That means don't take out your freaking wild turkey, take out the other alcohol, because you don't want to give up your lunch, right?
But in the beginning, everybody was handling those with oily gloves,
Yep.
with the gloves on and
Yep.
stuff, and it was a huge problem.
That's probably why we were only getting 8,000 miles out of the plug.
Ball bearing grease.
Yeah, well, whatever, I mean, you.
What was caused? What are some of the causes of handling it? Like,
You'd get a misfire, mostly, a high misfire code,
oh.
and it would crack the insulator, and then the problem. We had some engines that was so bad, you could literally see the arcing outside the plug and through the boot. It burned through the boot.
Oh, so it would cause it so that it wouldn't send a signal or the electrical straight.
Yep. It's so busy traveling outside the plug, there wasn't enough pressure to jump the gap. So, they still require that you use 2 sockets. A magnetic socket to install the new plug, and anything else to remove it. Okay, if you look at a standard spark plug socket, they got that neoprene rubber to hold the plug in there. That neoprene can damage these plugs. You used to take the old fuel line tubing and put it over the top and thread it out. That can damage the plug, allegedly, according to Cummins. So they want you to have 2 sockets. And it's actually proven that if you have a mechanic who doesn't give a hoot and he's using the old style plug socket with the neoprene, it's actually showing up as this thing's coming in for plugs again. Okay, so apparently there's some truth to that. Okay. So you got a clean magnetic socket for going in, and then you got the old standard issue for pulling them out.
So you have to have a special socket. Is it, you can't use the one with the rubber inside of it?
To take them out, you can,
Yeah.
but to install the new ones, you cannot.
Oh.
We'd have that, just that's all it would ever be used for, nothing else.
Yep. Installation.
Is it a steel socket or?
It's a standard
clean.
spark plug socket. It looks just like everything else, except it doesn't have that rubber insert, and it's magnetic
Oh, it's magnetic.
to hold the plug.
And it's clean.
And it's
Oh, so you can't drop it.
And it's clean.
It's magnetic. Oh, it's
well,
real clean.
yeah, it should be kept
The
clean.
cleanliness is the key.
Yeah.
Okay.
It's like the clean room at the machine shop.
I can understand.
Stop that! Because I can just see some idiot sucking on one. When's the alcohol kick in? Anytime now, Sporto. Anytime. That's a go. I like that.
And then don't drop them, because if you drop them, you're done.
Supply.
Any spark plug, if you drop it, don't install it.
Yeah.
Just leave it there.
Yeah.
Well, crap.
Yeah, leave it on the floor, yeah.
Put a bucket in the
Just
box.
leave it there.
Probably.
No, don't do that. 'cause then somebody-
I could just see some guy with a spark
Just
plug
jack
and some
them
electrical
upside
tape
down.
wrapped around it.
It's not in the course.
Oh, yeah.
It's not worth the risk.
Going
Yeah,
on.
Bang it.
Now, we have another input into my ignition system that is very important. Okay, while it's not a primary input, what it does do, kind of indirectly, is it verifies that the ECM is firing the cylinder at the appropriate time. So, if I have a cylinder that I fire too early, and I successfully ignite the fuel-air mixture in the combustion chamber, and it ignites, and it starts releasing its heat, rapidly expanding with the piston out of position, that piston's going to come up in the bore and strike that pressure wave coming down the bore. And it's going to cause a knock. So I have knock sensors that are tuned to the frequencies commonly associated with that kind of an occurrence where the piston strikes the pressure wave in an upward motion. So what it does is when it hears that particular noise associated with the piston striking a pressure wave, it starts backing the timing off. It starts to retard the timing 6 degrees. So when I retard the timing, is the piston higher in the bore or lower in the bore? Higher in the bore. If I fire the spark plug off early, it's lower in the bore.
Yeah.
So if I fire it too much in advance, and it hits the pressure wave coming down and makes that knocking noise, the knock sensors hear it, they pick up the frequency generated by the noise, and they start backing the timing off in 6-degree increments until we're not hearing that noise anymore. Okay?
Piezoelectric.
Yes, piezoelectric. Now, it can retard if it's a heavy knock. It's a really heavy knock. It's actually going to start taking away throttle as well. Because if it's hearing this knock, 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 and you're like, whoa, this ain't good. Now, if you're not smart enough to get out of the throttle over a period of time, it's going to do it for you. Okay? Now, this could be associated with a cold start, where the fuel and the cylinder temperatures are not at peak temp and pressure, so you've got an erratic ignition. Okay? Now, the way you can check this, and I had to verify this because we have one nut job in Long Beach that didn't quite get it. I said, take a hammer and tap the block next to the sensor. And it'll hear it, you hear it drop the engine RPM. This guy's whacking the sensor. It's broke. Well, you just hit it with a hammer when you told me to. I said, no, I said hit the block next to the sensor. Oh, you mean I wasn't supposed to hit the sensor. Come on, give me the hammer. Come here.